Most welcome. Today we will talk about the next generation software technology. And with me I have a beautiful panel. Two of you are here in the studio, Vi and Jürgen. And then we have Anders on board, digitally, well, through the space. Are you there, Anders?
Yes, I'm here.
Okay, well, looking good. That's is that a library, or where are you sitting?
More or less spare time things.
Well,
whenever you have that.
So we get it right. I said that it's best that you introduce yourself, so you have the right titles and the way you want it to be presented. So Anders, tell us, you're at Ericsson.
Yes, so I'm running what we could call radio network software systemization, meaning in the Ericsson radio network product, the cell phone networks, how the code works and what functions we should have in it. That's my task.
Okay, great. And you will give us the perspective of being, well, within a big international company, your way of how you develop, and tell us the story about how you deal with all the challenges, all the opportunities when it comes to the next generation software. So good to have you with us. And then we have Vi.
Thank you.
What's the short presentation of you, Vi?
Well, I would say I'm a PhD student, halfway to my PhD at Kring Institute of Technology. Yeah, and my research focus is software testing. I would say that's all. Yeah.
And here at the Blekinge Tekniska Högskola, do you meet Jürgen once in a while?
Well, recently we met more often than before, and I think I haven't introduced. He's actually my supervisor.
Okay.
Yeah.
So has he been your teacher?
Yes, of course.
Yeah.
Yeah. I also took courses from him when I was doing my master degree here. Yeah.
Well, it's many years ago.
Yeah.
Back. Okay. And Jürgen.
Yeah. My name is Jürgen Börstler, and I'm a professor of software engineering here at BTH, Blekinge Institute of Technology.
Yeah. And since you have the perspective of the academia, and I'm thinking of, we start with you, Anders. Can you tell us about how do you work with software development within Ericsson? Because you're a big company, you have to develop a lot. It's very complex. So just give us your thoughts about how do you do it?
Well, like you say, Ericsson is a fairly huge company. We're a bit more than 100,000 employees, and I would say a quarter of those are in R&D, product development. And out of those, we have thousands of software developers. I'll focus on perspective of some parts, but it's not enough time to kind of really go through everything we're doing. But let's say on the radio network side that I come from, the software part that we have is sort of the core that make the radio networks function. You could say that you have a hardware part and a software part. For us, the software is something we deliver to our customer as an important piece of the product. It's not just, you could say, in a base station, you have both the hardware that you tie up on a pole, that you put in the cabinets, and then the software that actually makes it run. And when it comes to running, it's both handling the function itself in the radio network, but also connecting to the outside world. So that's one thing that we're doing. You could talk about the development of the product, but equally important for us is just to develop the production machinery, the things that we could actually allow us to write the code for our product. So we're both developing our production environment as well as our products.
But since you're a so big company, I've understood that many of the biggest companies, they have, different teams in different time zones around the world. So when one team, they have, stop for the day, another team, takes on the same area, the same subject, and develops it. And the next day, the first team will get, the same thing, but in a better version. Is that a way you're doing it?
Yeah, partially you could say that. We do have teams globally, so there are people working 24/7 with different parts of our code. And in many cases, it's the same files, the same repos that they're working with. Adjusting, adding different pieces to it. We really do this, like you say, it's about teams. Most of our software development is based on cross-functional teams that are responsible for a certain piece, so adding a certain function. So that team as such is seldom split over time zones. So different teams add different pieces, but they're working in the same software environment that we keep updated continuously.
Would you say this, Jürgen, is this a normal way of doing it as a big company?
Yes, I would say this is pretty common to work in that way. And in particular, bigger companies have development offices all over the world. Yeah. And it depends a little bit. So Anders was talking about cross-functional teams, and this is also very common. So you have people with slightly different backgrounds in your teams. So that.
But is it common in a good way, or is this there hasn't been very much development in the way of how we develop?
It depends on whom you ask. So developing software in globally distributed teams, or if you want to call it outsourcing, there are two sides of the coin. So you need to outsource because you cannot get enough skilled people locally, but there is an overhead to it, and it not always pays off. But
and what would you say is the problem?
Rework, communication.
Yeah. Is that the case? Rework and communication. Do you have some kind of problems with that during this global process, Anders?
Let's phrase it like this. I hope we don't have too many problems with reworking or waste in that sense. Communication is, of course, always a challenge. And this is a little bit, the important thing is you divide up the tasks in sufficiently, I could call it, independent pieces. So that's a bit when you look into software technologies, how much we work with different, or you could call it software containers, independent modules. So a little bit how you structure the code. So even if the same code, different teams work with different parts in it.
Yeah, and you are very you're very focusing on the testing process.
Yes.
So if your perspective, big company, a testing process, what would be the normal way of testing within a big company? And then we can hear with Anders if that's the way how they do it.
Yep. So at least from what I have learned, I think that for big companies, they focus on automatic test case testing, because that's like we mentioned before, that actually save a lot of time and effort, and eventually that's a mainstream in the industry. At least that's what we have seen.
Yeah.
Yeah.
So is that a way? How do you work with when it comes to testing, Anders, in Ericsson?
Well, you could say we have multiple layers of testing depending on the integration level, because it's the code part of the software we're working with is so big. So it's even, let's say, the design teams themselves with their own testing just of the work they've done, the smaller modules. And then you have, like we talked about, automated testing in larger test loops that we run continuously to ensure that we have a stability in the code. And then you have, at certain time, you do more thorough, in-depth testing before you release software to customers. And every now and then, there are also special types of testing, if you could call it interoperability testing, where we test with various partners that our equipment can work together with theirs. For instance, our networks with the phones from different vendors.
Are these techniques, the ways of doing it that you know of?
Yes, at least I have seen. I have read about those techniques also in the literature. Yeah.
But since if I compare your company with others, if you have Google and Facebook, I realize that they are testing. We are using us as customers all the time as testing their software. But since you're doing base stations and do you have the same possibilities of testing like companies like Google or Facebook, or no, we don't have that opportunity. We have to be sharp at every second. Can you compare it?
Yeah, well, in a way, I would say we are quite alike when it comes to we have massive software solutions, and just even I do hope that Google and Facebook do a lot of testing before they release any beta releases out to the general public, and you can say that type of testing is, I would fairly similar to the needs of testing that we need to do. Then, of course, towards the end customer, they have millions or billions of customers. We're talking about hundreds or thousands of customers, which in turn have millions and billions of customers. So it's slightly different in the very end of the test, you could say. But general test strategies and test methodologies for the software part, I would say they are probably very much alike.
What are the hardest, bits to test for Ericsson, since you're very, complex, national systems in many ways? What are the most crucial parts of testing?
I would say if you talk about, let's me take one example. When you talk about something as telecom grade, you talk about something having 5 nines. That's 99.999% availability. And if you say that it's between, there should be different failures. And just doing the math, how long do you need to run something and to identify any potential problems, so you could say you could guarantee that you have an availability that's this high. Then of course you test the same thing many times in parallel test systems, so you could shorten the test time because of that. But there are certain things when it comes to stability, availability, that is just tedious to test.
Jürgen, any thoughts?
Yeah, I think this what Anders is saying is very important, because downtime is an important thing for critical systems. You cannot have it like in Windows. There is a system update, please restart. You cannot restart the base stations, because if you do that too often, Ericsson would probably be out of business pretty soon. So there is there are
definite differences.
There are much higher stakes.
Yeah. Yeah, and what can you hear about testing from Ericsson perspective? And any other thoughts about how they? No, we can.
Yeah.
I can take another question. We're talking about the team, the importance of it. Well, the big companies, where plenty of developers, and you have to work within teams. So, from a researcher perspective, what are you? What would you say is that's the typical way of doing it? 2021, 22.
I think if you look very long forward, I think there will be bots, automated, artificially intelligent tools within those teams that would interact with the developers, and they need to communicate in a smart way, and the developers can offload more simple, repetitive work
to the bots.
To the bots.
Yeah.
And
will there be
also
testing bots in these teams as well?
Well, I would say yes. Why not? I mean, they're actually basically the same. I mean, you also need to write code for testing. So now, if you have the bots that can help developers, so you could have also bots to have testers.
And Anders, is this the way you're thinking about the future as well? The way you will organize your testing and your teams? Tell us.
I would say software craftsmanship is, you could say, really a discipline, and it has really changed over the years. With what Jürgen refers to, there are new tools coming in, if it's bots here now or other functions as well, that definitely help out. So they mean that the developers will they will shift their focus on the more advanced tasks, or where at least you could say the man in the middle is the important part. So the development, how we work, that's changing continuously.
Well, but when you say develop, well, since I'm a bit from the outside, and I think, well, he's a developer. That's for me. Well, and that's one profession. I'm a coder. Do I have a very old school way of looking at it? No, we shouldn't just say developer. We should have 20 words for different kind of different kind of craftsmanships here. Do we have a language among the people on the outside that we should learn how to treat these as totally different professions in many ways, or is it good that we use this? Well, I'm a software developer. That's the one word.
Yeah, it depends a little bit on where you are. So in the Anglo-American context, people call themselves often as software engineers.
Yeah.
And we would probably call them coders. But there are software developers, testers, system
many
architects.
Specialities.
There are many specialities, and you need many specialities because the systems have become so complex that you cannot know everything. There are back-end and front-end developers. There are user interface
if you're
specialists.
not used to, since that are new words for me, I've just a couple of years ago I didn't know what back-end and front. If I've never heard of that. What would your description of back-end and front-end?
You could say a front-end developer would, for example, deal with more closely to what the user is seeing.
Okay.
And the back-end developer more with how the data is handled and stored in databases, for example.
Okay. So more design at the front end in some ways.
Yeah, it depends also a little bit. So even on the front end, you can do design and development.
Anders, how do you divide your staff? Do you have different? What are different specialities you use?
Yes, quite a few. And I would actually take as an example another analogy here. If you go to a hospital and see a doctor, I don't know how many different types of doctors you could find. Most would still call them a doctor, but they might be a pediatrician, a surgeon, or a general practitioner, or whatever. But from people on the outside of the hospital, well, they're just doctors.
Yeah.
For us,
I
it's the same thing.
it, but is this a problem, though, that we don't have the vocabulary for this?
Well, no, I don't think so. You could say it's a way how the software engineering, the coder, developer, how that, you could say, that trade actually develops. For people coming in, they might be doing something at a certain period of time. Then as they grow more experienced, if they turn into a more architect style or some of a lead designer, or you talked about testing also, that's you could say in some cases is a sub-discipline within the software engineering area. So I think it's from the outside, of course, it's good to understand that it's not just one type of role you have. There's many of them, but I think it's very hard from the outside to understand what all the different involve, what they mean, so to say.
Yeah, but since when I researched, I read, we are lacking the engineers for programming, and couldn't it be easier to attract more people if we had a better way of looking at this? I understand. I don't need to be a nerdy guy because I have this other perspective, and that's useful. Do you agree?
Yeah, I would agree with you because it made me think like if I was a student and I want to be a developer in the future. So actually, before I started anything, maybe it's also good for me to know some about the vocabulary, like what specialties that a developer could have or can have, and then you actually that would be good also for your career in the future.
Jürgen?
I completely agree. So you shouldn't underestimate the social skills that are necessary to work in a good cross-functional team. So it's not always the very best and most skilled developers that work best in such schemes, such teams. So it's really important that you have both, so the skills and function well in a team.
I'm thinking about, since we're talking about bugs here also, what will when we would talk about let's say this, let's put it this way instead. We talk about quality and cost, and always, well, it seems to be a contradiction there. Must that be the case?
At least in my opinion, in the ideal scenario, that should not be the case, but there's a trade-off. So if you want to have high quality in your software, you need to invest more effort in developing it properly, in testing it properly. And in order to have that much investment, this means you also have to pay extra.
And
so
do you agree?
Yes, I completely agree. So there is no free lunch, and that's in quality as well. You can invest in better tools, in educating your staff, and that pays off at some point in time. But more quality typically costs more.
Yeah. Do you agree, Anders? Do we have a shortcut to keep high quality and lower costs, or do it have to be it has to get the big fundings to get rid of the bugs, the problems?
I think Jürgen is a bit spot on here. Of course, some form of investment is needed. One is just coming back to the experienced people. The more similar problems you looked at, the faster you'll probably learn how to handle something, and hopefully the product quality increases. But it's also, again, about investing in other or newer tools that are more efficient when it comes to testing or code checking or whatever you have, looking from quality aspects. And then, of course, continuously training your own people, so that they know more.
Do we have less or more bugs nowadays than earlier? Anders?
That's a very good question. We still find bugs. We hope we find them earlier, because the earlier in the process we find them, the cheaper they are to correct. The worst is something if we find a bug out with one of our customers when they're using our products, that's not good. But if we find it during development, the XFT, our cross-functional team, finds it themselves, that's a fairly simple thing to correct. And again, you learn from your experience. You gain your experiences from also doing mistakes. But I hope that the mistakes you make are cheap ones to correct.
Okay, great. Well, a final question. Since I believe there are young people watching this clip, this discussion, and I'm thinking I'm quite interested in getting into these areas about coding, and I might go to Ericsson if that's a possibility. I'm thinking about what will happen in the future. Will we write code in the same way that we do today, or will the bots and the AI take over, so there will be totally different professions in the future, or is it, well, it's a good idea to start coding today? What are your thoughts about the future? Anders, you start.
We'll definitely write code in a different way. Exactly how, I think we don't even know yet. But to have that sense of how software is working, how to write code, will also be needed in the future. The more specialized systems you have, the more skills you need in this.
Okay, thank you. Jürgen?
I completely agree. We will probably write code on a higher level, and then take this level to generate more specific code. But at some level, we will still write code even in the future.
Yeah.
Yes, I will agree with Jürgen and Anders. I remember I read an article saying so they use machine learning in actually try to generate code, production code. So what they did is that they just write a command. So basically the idea is that, okay, the command's on top of the method. So what the method is supposed to do, and then they give that to the bots or the AI models, and that AI would try to write actually the actual code of the method. But as you see here, actually there's still the need of the human guidance, even though you involve the bots. So we just go to a higher level as a human being when we write code, but maybe the lower level would be done by the robots itself.
Okay.
Yeah.
Interesting. When I think of software development, the word efficiency comes up in my brain. How does this fit into the development? Anders, any thoughts about efficiency?
Well, for us, it's quite important in the sense that we have a lot of state-of-the-art hardware that we develop ourselves, and we need to have the software really running efficient on this hardware. And that's both because how users will perceive the systems, talking about what you have delays and things, but also not the least important, it's about energy consumption. Because the more things we do with software, the more systems we run, we can't let them consume too much energy, of course, because here is something we need to improve.
And you have also the discussion about resilience. If we run into problems, I believe that's close.
That's also close. You need to have the resilience, the stability to kind of handle the unexpected.
Yeah, and in a environmental friendly way.
Yeah, of course. So the systems, if you go way back, so we had systems that didn't communicate with each other, but nowadays we have systems of systems. So you cannot do something in a system in one system and don't expect that this doesn't have effects on other systems. And if you have an outage somewhere and the electricity is going down, this will have effects on other areas as well. And so one problem in efficiency might lead to a shutdown elsewhere.
Yeah.
So that is very complicated.
And when we talk about shutting down, this will be the final statement. So, well, thank you all for this very interesting discussion. Anders, thank you for participating from your library.
Yeah, thank you.
Thank you. Jürgen, very nice meeting you. And thank you everyone who's been following this discussion. I hope you enjoyed. Thank you so much.
Thank you.
Thank you. Yeah.